All right, hello everyone. Professor Clark here. I've decided to try and do this a little bit differently. As you can see, I've got a whiteboard behind me, and so I'm going to try and walk through the math that we've been discussing up to this point using the board. The feedback that I get every semester from students is that they prefer to see it on the board. I got this big board from up at Ferris, and I'm going to try to walk through the quantity takeoff math doing it that way. I've done this for my other class, my BCTM 213 class that most of you will take next year, and I've gotten good feedback from it that they've enjoyed the video and it helped them understand the math. Okay, so again, I'm going to try and do that for our quantity takeoff. All right, so at this point, we again are referring to our practice copy. Okay, so everybody should stop the video and get that out so that you can refer to it as we walk through. You can understand the dimensions and all of the different information that I'm going to talk about. All right, so again, at this point, we start with our list that we've looked at several times in class. Okay, and then we can see that we are up to item number 7. We so far have determined our quantity of concrete, our lineal feet of rebar for our footing, our number of corner block for our foundation, our 12-inch foundation, our number of 12-inch block for our foundation, our number of 8-inch corner block for our foundation, our interior foundation, and our number of 8-inch standard block for our 8-inch interior foundation. Hopefully everybody is keeping up with the math at this point. I'm not going to revisit what we've already determined because we touched on this before we left Ferris, and I provide you with those Word documents, so I think where we're at is a good place to keep going from. Okay, so we can see as we look at our list, okay, that our next item is our bullnose block, okay, for our wall. All right, first off, you can pause the video and Google images of bullnose block. Okay, you can also refer to the masonry handout that I provided for you. But what is a bullnose block? A bullnose block is an accessory block. Okay, if I'm looking down on a block, okay, like this, I'm looking down on that block. Okay. My standard block has just got standard edges, okay, on it. Okay. A bullnose block has got one edge that is softened or rounded, okay, and that should be obvious. That is for an opening that I can go through, okay, and soften the edge of that opening. Okay, that's why we use a bullnose block. Rather than having that sharp edge, I can walk through this opening and have that softened edge, and it just looks nicer. Okay, it is an accessory block, just part of all of the different types of block that are out there. Okay, part of the masonry industry, as we discussed when we lectured on masonry. Okay, so when I'm thinking about my bullnose block, what am I saying then? I'm saying that that bullnose block is going to go on the edge of all of my openings. Okay, so if I have my building here, and I have a door, or I have a window, okay, that bullnose block is going to go on the edge of each one of those openings. So as I look at that, I have to understand, therefore, the height of each opening. The same thing would be true right here with my door. If I'm looking at my door and I'm understanding how my block is laid next to the door, okay, I see that I am going to understand that my bullnose edge is going to be right there at each one of those blocks. So again, I'm concerned with the height of that opening. Okay, all of my openings. And I'm concerned with the height of my block. Okay, well, we know the height of our block is always what? It's always 8 inches. Okay, because we've said many times that a standard block is 16 inches long by 8 inches high, and then the width can vary. Okay, so again, information that we've already looked at. All right, so what do we need to do? We need to understand the height of all of our openings. So again, we refer to our print. We refer to the communication that is given to us by the design team, and we look through our information. Okay, if I look at my elevated view, okay, I can see that I have some doors and windows. If I look at my plan view, okay, my floor plan, I can see some information regarding my openings. I see that I have this big opening here, and that's 12 feet wide. I see that I have a window right here, and I can see that they give it a name. They call it window number 2. I can see the same thing with my door right here. They call that door number 1. I can see this is called door number 2. I can see different symbols used for windows as opposed to doors. My windows are a 2 in a circle or a 1 in a circle, and my doors are a 1 in a diamond or a 2 in a diamond. Okay, so again, they're starting to communicate that information to me. Okay, but we've already talked about what are we concerned with. We're concerned with the height of our windows and doors. Am I given that information here? No, I'm not. Okay, I'm given how many I have, but I'm not given the height. Okay, same thing here on my foundation plan. I have no openings on my foundation. Okay, my foundation is my foundation. So we finally get to the last page of our little print, and what do we see? We see right here that these are called window schedules and door schedules. Okay, so I look at it. I have a window schedule on the top, and I have a door schedule on the bottom. And it gives me all of the information that I'm looking for. It gives me the height of each one of those windows, and it gives me the height of each one of those doors. Okay, but it doesn't give me how many I have. That I have to go back to my floor plan, and that gives me the number of. Okay, so again, having to use more than one sheet of my print to understand the information I need to understand, because I need to know the height of each window, and I need to know how many there are. I need to know the height of each door, and I need to know how many there are. So the combination of this view, my floor plan view, and my schedules, my window and door schedules, I can determine that information. Okay, I can determine the height of each one with my schedule, and I can determine how many I have with with my floor plan. Okay, so everybody refer to your floor plan, or refer to your print, your information as we walk through this. Okay, first we can see that how many different window types do we have? We have 2 different window types. Okay, so I have my windows, I have type 1, and I have type 2. Okay, then I have my doors. I have type 1, I have type 2, and I have type 3. Okay, again, referring to my schedule, I can see that, or I can see that here on my plan view. Okay, it tells me that I have type 1, type 2, and type 3 of my doors, and I have type 1 and 2 of my windows. Again, going back to my schedule, I see the same information. Okay, I have type 1 and I have type 2 of my windows. I have type 1, 2, and 3 of my doors. Okay, so we list those out. Okay, the next thing we're going to do is we're going to list out what? We're going to list out the height of each one of those, because that's what we're concerned with. Okay, so for my window number 1, my height is 4 foot. So I have 4 foot. For my window number 2, same thing. I have a height of 4 foot. Okay, for my doors, okay, for my door number 1, I have a height of 7 foot. For my door number 2, I have a height of 7 foot. And for my door number 3, I have a height of 8 foot. Now what do we need? Now we need how many do we have of each? Okay, so I go back to that floor plan and I count them up. Okay, everybody should be able to look at their floor plan and count them up. Okay, to our windows, I have window number 1. Let's see, I look at my print and I see I have how many of them? I have 1. So 4 foot times 1. Okay, I look at my window number 2, I can see I have several. I've got 1, 2, 3, 4 of them. 5 of them. I've got 5 window number 2. Okay, now I can determine the height of all of my openings for my windows. I can do the same thing with my doors. How many door number 1s do I have? Okay, we're talking about our 8-inch block for our wall, so it's every opening. Okay, so I can see that I have 1, 2 door number 1s, and I have 1 door number 2, and I have 1 door number 3. Okay, so by multiplying those and then adding all of that information up, I now have the height of all of my openings, and that is what I am concerned with. So we go ahead and walk through that process. 4 times 1 equals 4 foot. 4 times 5 equals 20 foot. Okay, so that means for my windows, I have a total of 24 foot worth of height. Okay, for my doors, 7 times 2 equals 14. 7 times 1 equals 7. 8 times 1, sorry, we've got only one of those doors. So 8 times 1 equals 8. I add that up. 14 plus 8 would be 22, plus 7 would be 29. So I have a total of 29 feet for my doors for my doors. Okay, so now I'm going to add those two numbers together. 29 feet plus 24 feet. So I have a total of 53 feet for my openings. That's what I need. Okay, so a total of 53 feet for my openings. Okay, but what do I know? What do I have? Again, we have to think through this process. What did I just determine? I just determined how many sides of that opening. I determined one side of that opening. Okay, I said, all right, I have this many doors. I have this many windows. I multiplied a height times the side of that opening, or times the number of openings. Okay, so now I have to understand that I need to do what with that number? I need to multiply it by 2. So 53 times 2, okay, so 6. So I have a total of 106 lineal feet of opening space. Okay, now what? If I have 106 feet total, okay, and I want to determine how many block I have at each opening, what am I going to do? Okay, again, here's my block. I know that my bullnose block right there is my softened edge. Okay, I have the same thing on this side. My bullnose block is that softened edge right there. Okay, what am I going to do? I'm going to divide by the height of that block. The height of that block, we know, is 8 inches. Okay, so if I have a total of 106 lineal feet of opening space, I'm going to divide 8 inches per block into 106 lineal feet. Okay, so we look at that. All right. Okay, so my formula is height of openings, all openings, in feet divided by height of block in feet. Okay, so now that means that I have 106 lineal feet total divided by 8 inches per block. What do I have to do? I have to convert 8 inches to what? To feet. Okay, so 8 inches divided by 12 inches per foot gives me what? Everybody get your calculator out and do it on your calculator. It gives me 0.67 feet. Okay, so I'm going to change that 8 inches to 0.67 feet per block. Now, my feet are going to cancel, and I'm going to get what? 8 divided by... I'm sorry, everyone. I had a calculator here a minute ago, and now I can't find it. All right, so I will be right back. All right, everyone, sorry about that. It was in my office. So 0.67 divided into 106 gives me 158.2. Again, we can choose to round this either way. So we could say 158 or 159. We'll use 158 bullnose block. All right, so we've determined how many bullnose block we need on the outside edge of every one of our openings. So we are going to go to our print, okay, and we are going to write, go back to our list, I should say, and we are going to write, okay, that number, 158 block for my bullnose block. Okay, so we've got 158 block, our bullnose block for our wall. Okay, now I'll take this opportunity to point something out. Okay, as we look at that list, what do I have? Okay, I can see that I've listed it a particular way. I have bullnose block that we just determined, then I have lintel block, which we determined next, and I have corner block, then I have bond beam block. Then finally, I have my 8-inch standard block listed last. All of those, if I look over to the right, are for the wall, okay? Why did I list it that way? Because at the very end, we're going to have to do what? We're going to have to subtract each one of those accessory block from our total number of standard block, because they're going to be ordered separately. I'm going to order my bullnose block separately. I'm going to order my lintel block separately, and on and on. Okay, so those will take away from the total number of block. Okay, again, thinking about the area that we've used thus far to determine how many block we have. Okay, so we write that in our list, 158 block. Okay, and now we see that our next one is our 8-inch lintel block. Okay, now what was a lintel? We already talked about that in class. What is a lintel? Okay, everybody should remember that a lintel is a piece of material that carries weight over an opening in a masonry situation. Okay, so again, if I've got a door, okay, or I've got a window, that lintel is a block that carries weight over that opening. Okay, so my lintel would be placed right there. Okay, and this would be my block as I continue up the wall. Okay, everybody should be able to visualize that and understand that. Okay, same thing would be true over the top of a window. Okay, I would have my block would come out to the top of my window. And as I lay that up, just like we did in the lab, and then that lintel would carry weight over the top of that opening. Okay, just like a header, for those of you that have any experience in wood framing, okay, or steel stud framing. Okay, I have to put a header over that opening to carry that weight across that opening. Same thing has to happen with masonry. The only difference is that instead of a header, we call it a lintel. Okay, now a lintel, and we've already talked about this, there are many different types of lintels. Okay, I could place a piece of steel right there to carry that weight over that opening. I could place a precast beam. I could form, reinforce, and place a beam. Okay, or I could use lintel block. Okay, we've already talked about this when we lectured on masonry. Okay, that's what we are going to use as a lintel block. Remembering what a lintel block was. Okay, so if I look at my block, okay, right here, okay, a lintel block would look like that. Okay, or if we look at it just on its edge, a lintel block would look like that. Okay, so I would place those block over this opening. I would put rebar in that part of the block, and then I would pour grout inside of that lintel block. Okay, and then once that grout hardened, I would have the same thing as a precast beam. I would have the same thing as a steel beam, a solid member that goes all the way across that opening. All right, so therefore, now what are we going to be concerned with when we're trying to determine how many lintel block we need to go over that opening? We're going to be concerned with the width of our openings as opposed to the height of our opening, like we just used when we determined number of bullnose block. We're going to be concerned with the width of the opening and the length of my block. Okay, this time 16 inches. Again, remembering that a standard block is always 16 inches long, 8 inches tall, and my width varies. Okay, but the first thing we have to do again is we have to worry about the width of each one of our openings. So what do? We do the exact same thing that we just did with our bullnose block, except now we're looking for the information concerning the width of our openings. So again, I have to make a list. I have my windows. I know I have window number 1. I know I have window number 2. I have my doors. I know I have door number 1. I know I have door number 2. And I know I have door number 3. Okay? So again, we go back to the same thing every time. Our communication, our print. Okay? And again, we see the same thing. I have my elevated view. That doesn't give me the information I want. I have my floor plan. Again, it does give me the information I want. This time, I could go right to my floor plan because I can see the width of each opening is given to me on my floor plan and the number of. Okay, so in this case, I could stay right with my floor plan. Or that information is also given to me in my schedule. Okay, so again, I look at my door and window schedule. You guys have this in front of you. With your window schedule, we can see that the width of each door is, or my windows, my window number 1 is 4 foot, my window number 2 is 6 foot, and on and on. Okay, so either way, I could take that from my floor plan, or I could take that from my schedule. Going from my schedule, again, the width of my window number 1 is 4 foot. The width of my window number 2 is 6 foot. Okay, again, my doors. Now I have the width of door number 1 is 3 foot, and I have the width of door number 2 is 3 foot. All right, now we have something we got to stop and think about. Okay, we can see that the width of our door number 3 is 12 foot. Okay, but now we go back to our list. Okay, and we see that in a couple more items, we have to determine number of bond beam block. All right, what is a bond beam? Okay, a bond beam is the exact same block as a lintel. It's the same piece of material, but it's not used to carry weight over an opening. Okay, the difference between a lintel and a bond beam, okay, the lintel, while they're both the same block, carries weight over an opening. A bond beam is a part of our overall reinforcing. Okay, and what that means is that I have to run the entire perimeter of my building with that same block, a lintel block, but now I've created a bond beam that ties my vertical reinforcing and my horizontal reinforcing together, giving me the strength that the engineers require. Okay, so my bond beam, while it's the same block, it's the same material, is a different system. Okay, so my lintel, I use a lintel block to carry weight over the opening. My bond beam, I use a lintel block to create a bond beam. Okay, so again, sometimes these things just have to be understood as we process through the construction process. Okay, and again, a very good example of having to have the ability to see something before it exists. Okay, you've heard that in all of your classes. That's what I have to develop. I have to develop that ability to look at a print and see something before it exists, okay, in order to do something like we're doing, in order to perform a quantity takeoff. I don't even have the job yet at this point, okay? I have to determine how many I have of each piece of material, and therefore I can determine how much it's going to cost to build this building, and therefore I can determine how long it's going to take to build this building. I can determine how many people I'm going to need to build this building, what size of a crane I need to build this building, and on and on. Okay, but again, the point is that we don't even have the project yet, and I have to understand this construction long before we ever actually build the building. Okay, so we look at that and we start to think this through. Okay, now I'm going to go back to my print so that I can understand what I need to understand. Okay, always returning back to that print, and I see what? Okay, I look at this elevation and I can see that all of those windows are at roughly the same height. I can see that my doors are at roughly the same height with one another, except for my big door right here. Okay, that's the tallest opening I have on my building. Okay, that big garage door is taller than all of my windows, and it's taller than all of my regular doors. So what does that mean? If my bond beam has to continue the entire perimeter of my building, the only place it can be placed is at the top of that door. Okay, so now my bond beam is going to act as the lintel for this door. Okay, again, that can be kind of confusing, but that's the ability that we have to develop. I have to be able to see that before I ever get there in order to have the ability to perform the quantity takeoff accurately. Okay, so understanding that, I can do one of two things. I can either determine the lintel for that big door, okay, the number of block I need over that opening, and subtract it out of my bond beam, or I can say I'm not going to determine the lintel for this door. I'm just going to determine the number of block I need for the bond beam and not worry about this lintel. Okay, either way would be correct. Okay, again, this is what's confusing to a lot of you. Who's setting this math problem up? Who's determining how I'm going to do what I'm going to do? We are. I am right now because I'm teaching you. Okay, but you will once you get into the field and you learn how to do this more and more. Okay, it's our responsibility to set this math problem up. I have to decide exactly how I want to perform that. Either way would be correct. Okay, as long as I have the correct number of block, the correct number of pieces of material that are ordered and brought to the job site, I'm going to be okay. Okay, but the point is that before I ever get there, I have to have the ability to set up and perform that math problem. So in our case, we're just going to say, I'm going to decide that we're not going to determine the lintel for door number 3, knowing that I'm going to determine that number of block when I get to my bond beam, and we will be there shortly. Okay, so therefore, I do not need door number 3, okay, for the sake of this quantity takeoff. Okay, so again, now I can go back to the information that I just determined, okay, and I can do the same thing by determining how many I have of each opening. Okay, so again, we can either look at our print or we can go back to our last problem, and I can say, all right, how many door number 1s do I have, or window number 1 do I have? I've got 1. How many window number 2 do I have? I've got 5. Okay, how many door number 1s do I have? I have 2. And how many door number 2 do I have? I've got 1. Okay, and again, we're saying, all right, what is the overall width, the total width of all of my openings? Okay, so I can determine that by multiplying all of these together and then adding everything up. So 4 times 1 equals 4. 6 times 5 equals 30. Okay, 3 times 2 equals 6. 3 times 1 equals 3. All of those are in feet. So I add them up. I've got 34 foot there, plus I've got 9 foot here. So 34 plus 9, okay, that would equal 43 lineal feet of opening. Okay? All right, but what else do I have to understand here? Okay, again, I walked you through the same steps as we just did with the last one, but understanding my lintel, okay, I have to take another step. Okay, going back to how a lintel works, if I have this opening, okay, and I know that my block takes me across my opening, what do I have to think about? I have to think about, all right, that lintel has to be beyond my opening. I need to know what that dimension is. Okay, I need to know what that dimension is. Again, is that something I'm going to determine? No. Okay, I don't have PE behind my name. The design team is going to determine that. Okay, so now, again, thinking about the different forms of communication we have, now we see that I need to get into the written form of communication. Okay, again, we've already discussed many times that the design team communicates information to me in different ways. 1 with the print, that's graphic. 2 with the specs, that's written. 3 with math, okay, and that's all kinds of different information, dimensions, slope, on and on, okay, all the different things that we have to understand. But in this case, we're going to look at our written communication. We're going to look at our specs. So everybody refer to that, okay, and I can see underneath there where it says lintels, okay, everybody sees that. Okay, if you look at the bottom of your specs, it says lintels, okay, and it tells me for my block, I have a bond beam, okay, or a lintel, okay, it has 2 number 5 rebar minimum, okay, and the support is 8 inches on each end. Okay, for my brick, and we're not there yet, I see I have 6 inches of support on each end, okay, but we're discussing our block, so we see that I have 8 inches on each end. What does that mean? What do I have to do? I have to add how much to each one of these openings? I have to add 16 inches, okay? So again, we see that we have a conversion factor. What do I have to do? If I've got 16 inches, I have to divide that by 12 inches per foot because I need to be in feet in order to add it to feet, okay? And that gives me 1.33 feet. Okay, so what do I have to do? I have to add 1.33 inches to this and rework my math. Okay. Okay, so 4 plus 1.33 is going to give us 5.33. 6 plus 1.33 is going to give us 7.33. 3 plus 1.33 is going to give us 4.33. 3 plus 1.33, 4.33. Okay? So we add that to each one of our openings. Okay, so now I'm going to have to walk through and do my math again. So 5.33 times 1, 5.33 feet. 7.33 times 5, 36.65 feet. 4.33 times 2, 8.66 feet. 4.33 times 1, 4.33. Now I add those together. 5.33 plus 36.65 equals 41.98 feet. 4.33 plus 8.66 equals 12.99. Almost there. Now I have to add those two together. So I get a total of 54.97, okay, or 55 lineal feet. Okay, so we've got 55 lineal feet of width for my openings. Okay, so total equals 55 lineal feet. All right, so now what do I do? Okay, again, back to our openings. And again, I understand if I've got an opening right here, and I've got my block coming up to the top of that opening, doesn't matter if it's a door or a window, and I've got that lintel sitting over the top of that, and I know that I'm building that lintel out of lintel block. Again, what am I concerned with? I'm concerned with the length of that block, or 16 inches. Okay, so what does that mean? I'm going to divide 55 lineal feet by 16 inches per lintel block. But again, we see that I can't be in inches. I've got to do that conversion. We just did it. 16 divided into 12 is 1.33 lineal feet per lintel block. Okay, so now my feet are going to cancel. And then finally, I'm going to get the number of lintel block that I need. So again, everybody should be performing this math as I walk through it on your calculator. Okay, so I get a total of 41.35 lintel block. And again, I can round that either way, okay? Math would tell me, the rules of math would tell me to round it down, but if I'm estimating it, okay, or if I'm ordering it, I would go either way. So 41 or 42 would be correct. So we'll say that we have 41 lintel block. Okay, all right, so we're all going to write that into our list so that we can keep up with that. And I'm going to write 41. And I have 41 lintel block. All right, we're getting there. All right, so now I've got my corner block, okay? Just like we saw with our foundation, okay? What do I say for my corner block? Okay, what's my formula going to be? So for my 8-inch corner block for my wall, we can go back to item number 3 or item number 5, and we can remember our formula. Okay, again, that's why it's important to record this information so we can refer back to it if we need to. Okay, and it's going to be number of block per corner times number of corners. Okay, just like we already determined. Okay, so once again, we refer to our print and we understand what I have to solve for in order to plug my numbers into that formula. Okay, so now we're looking at our floor plan. Okay, we're not looking at our foundation plan anymore. Now we're building our wall. So we're looking at our floor plan. Okay, and what do I see? How many corners do I have? Okay, I'm building these outside walls out of 8-inch block and that interior wall out of 8-inch block. Okay, we go to our section cut to understand that. Once I'm above my foundation from here up and from here up, it's all 8-inch block. Okay, so now I can say I have how many corners? I have 5 because I have 4 corners on the outside and I have 1 corner on the inside. Again, remember that we've been setting up this math problem the whole way through. Okay, and we said that our exterior foundation took us from here to here. Okay, so we did the same thing on the interior foundation. We said we're going to go to the top of the same block. Okay, knowing that I was going to have to determine this block eventually. Okay, I need to know the height of that wall from foundation up. So we made the decision that we're going to call the top of the foundation right there. So I can determine this height, which is going to be the same as the top of the foundation there. So I can determine this height. Again, could I have done it differently? Yes, I could have said that this block is 5 inches high and 5 block high, and this block were 4 block high. But again, why would I do that? I'm going to try and think this all the way through so I can save myself steps and say that, okay, I'm going to call this one 4 block high and this one 4 block high. Then the height of my exterior wall and the height of my interior wall above my foundation will be the same. Okay, that was the determination that we made back when we were still up at Ferris. Okay, so now what do I need to do? Okay, I need to utilize my elevations. I need to subtract one from the other so I can determine how tall my wall is. Okay, so I take my top elevation and I take my top of foundation elevation and I subtract those two. Okay, so again, everybody should be looking on with their print. So my top elevation is 980.00 feet. My top of foundation is 963.34 feet. I subtract those two and it will give me the height of my wall. Okay, so I go ahead and do that. So we can do it on our calculator. Yeah. So we get our wall is 16.66 or 67 feet tall. Okay, pretty tall wall. Okay, but that's what we need to know. We need to know how tall our wall is. So it's 16.67 feet tall. And we do that by subtracting one elevation from another. Okay, so height of wall equals 16.67 feet. All right, so we've determined that. Now what do we need to determine? I need to know how many block I have in each one of those corners. Okay, we already determined by looking at our print that I have 5 corners. Okay, now I want to determine how many block I have per corner. Again, we determined how tall each one of our walls are, or how tall each one of our corners are. So what am I going to do? Again, what am I talking about? I'm talking about the height of my block. Okay, again, we've got a standard block. It's always 16 inches long, and it's always 8 inches tall. Okay, we've already done this math. We've done this math several times, actually. Okay, that's why it's important to keep good notes. Okay, keep your information in those boxes that I provided for you so that you can refer back to that all the time. Because why? What did we say? We said 8 divided by 12 equals what? 0.67 feet. And that's what we want. Okay? Because I'm going to say 0.67 feet per corner block divided into the height of my wall. 16.67 feet. My feet are going to cancel, and that's going to give me number of corner blocks. So I perform that math. Okay, so 16. And I get 24.88 block per corner. I'm sorry, I get 24.88 corner block. Okay, so now I could round here if I wanted to, say 25 times 5, or I can round at the end. Again, we said we're going to determine that we're going to round at the end. So here I have 24.88 block per corner. Okay, and I have 5 corners. My corners are going to cancel. I'm going to do that math. 24.88 times 5. And I'm going to get 124.4 corner block. Again, I can round either way. I could say 124 or 125. We will say 124 corner block, 8-inch corner block. Okay, so again, we are going to put that into our list, 124. And we're moving down our list. We've got 124 corner block. Okay, everybody should be keeping up at this point. All right, so let's do one more, and then we'll call that good for this video. Okay, so again, looking at our list. Okay, looking at our list, what's our next item? Our next item is 8-inch bond beam block. All right, so what did we say? We said a bond beam is, again, a system that continues all the way around the perimeter of the building. It's part of my overall reinforcing. Okay, so again, what I'm saying is that as I look at my plan view and I understand okay, I'm saying that block is going to continue all the way around the perimeter of this building. Okay, my print, my details would tell me exactly that. Okay, as I look at my print, if I look at my section cut, Okay, as I look at my section cut right here, I can see it. It says there's my bond beam right there. Okay, shows me bond beam. It shows me the rebar inside that bond beam, and then that would be grouted full. Okay, again, it's at the top of the highest opening, which is our big overhead door. Okay, all right, so what do I need then? I need the perimeter of the building. Okay, have we figured that out? Yes, we figured it out a couple of times. Okay, so we go back to our notes. We can figure it out again if we want to. We go back to our notes of where we've been keeping up with everything. Okay, and I look at those. Do I want the perimeter of the concrete footing? No, I don't. Okay, I want to go all the way to where I determined the number of 12-inch block for my foundation. Okay, and remember what that perimeter was. Okay, so again, if we go to number 4, okay, item number 4, okay, we hopefully recorded our information well. Okay, just like I talked to you at the beginning, we want to record that information well so that we can refer back to it all the time. We can see that our net area, okay, is going to be our perimeter times our height of block, okay, our height of our wall. Okay, so I'm looking for it in mine, of course. So our perimeter all right, I don't have it in my notes. All right, so therefore I am going to stop right there. Okay, we will look at this one next because I have it. I just don't have it with me in these notes right here. Okay, so at this point, again, let's review what we did. Okay, let's look at our list up to this point. Okay, we've looked at 3 more items. Okay, and next time we will look at a couple more items and we'll continue with our math. Okay, so again, what do you want to do? You want to take this video, you want to go through that practice problem, understand it, then you want to go to your assignment and perform the same math using the information that's on the assignment. Again, no, it's exactly the same as this. The only thing that's really different are my dimensions, and I want to walk through those same steps, okay, and understand that math. Okay, so I will see you guys on Monday. Okay, and we will go through some more math, and we will continue through with that assignment until we walk through the entire list. All right, so hopefully this worked out, and hopefully this is a good way to do it continuing forward. All right, thanks, and see you next time, guys.